Hello students and welcome to this session. The title of my paper today is Plant Physiology BOC 104. So what am I going to do today? Which lesson am I going to teach you today? The name is Red and Infrared Light Responses on Photomorphogenesis. It is from the Unit 9, that is Plant Response to Light and Temperature. I am Maria Beatriz de Souza, Associate Professor from St. Xavier's College, Department of Botany. So what is the outline of today's lesson? 1. Phytochrome-mediated photomorphogenic responses in plants. 2. Examples of photomorphogenesis in plants. And 3. Role of phytochrome in photomorphogenesis. So what will be the learning outcome at the end of this session? It explains the concept of photomorphogenesis, cites examples of photomorphogenesis, understands the relevance of phytochrome and photomorphogenesis in plants. What is photomorphogenesis? We shall see the definition here. Light is a major factor controlling plant life in different ways. It also controls the appearance and development of plants, that is morphogenesis. The control of morphogenesis by light is called as photomorphogenesis. So this is the definition of photomorphogenesis. In plants, red and blue light are specially effective in inducing a photomorphogenetic response. What are the stages of photomorphogenesis? According to Hans Mohr, 1983, there are two important stages of photomorphogenesis. 1. Pattern specification, and 2. Pattern realization. What is pattern specification? Here cells and tissues develop specific ability or competence to respond to light during certain developmental stage. And pattern realization, during which time the photoresponse occurs. So what are the plant responses to light signals? Well, there are two main categories of plant response to light signals. One is phytochrome-mediated photoresponse, and the second one is cytochrome-mediated response. Phytochrome-mediated responses, as you can see in the brackets there, is red and far red light responses. Whereas cytochrome-mediated responses, you can see in the brackets put there, are blue light responses. We today in this lesson will focus on phytochrome-mediated responses in plants. Before we focus on that, we shall first see what is phytochrome. Large number of photomorphogenic responses in plants are known to be mediated by the proteinaceous pigment, the chromoprotein called as phytochrome. Now this pigment acts as a photoreceptor and it absorbs most strongly, please note most strongly, red and far red light. It also absorbs blue light, but most strongly red and far red light. So here you have an elaborate definition of what is a phytochrome. It is a proteinaceous pigment that acts as a photoreceptor and absorbs strongly red and far red light. It also absorbs blue light. It has a major role to play in every stage of development, from seed germination to flowering. Phytochrome is a soluble chromoprotein with a molecular mass of 250 kDa. It occurs as a dimer made up of two subunits. Each of these are 125 kDa each. Now each of the subunit consists of two components. One component is chromophore, that is the light absorbing pigment molecule, and the second component is the apoprotein, that is the polypeptide chain. The pigment phytochrome exists in two forms. One is the red light absorbing form, which is designated as PR form, and the second is far red light absorbing form, designated as PFR form. Now both these forms are photochemically interconvertible. When PR form absorbs red light between 650 to 680 nm, it is converted to PFR form. And the PFR form absorbs far red light 710 to 740 nm, it is converted to PR form. You can see here on the slide, the PFR form of this pigment is the one which is physiologically active form. Now here in this picture, whatever I have explained to you in the earlier slide is depicted. The entire explanation what I give you in the earlier slide can be seen in this one peak. You can see that there are two forms, PR which is the inactive form here. You can see PFR which is the active form. You can see that they are photochemically interconvertible. You can see the two arrows denoting that. And of course you have seen the red light and the far red light on either side of the red arrows. Next, we shall see the difference between PR form and the PFR. So the first point of difference is it is blue-green in color, whereas PFR is light green in color. The second point of distinction, it is inactive form of phytochrome, whereas PFR is the active form of phytochrome. The third point, being inactive, PR does not show phytochrome-mediated responses, but PFR, being active, shows phytochrome-mediated responses. Fourth, PR has maximum absorption in red region, whereas PFR has maximum absorption in far red region. Fifth, PR, it is converted into PFR form in the presence of red light, whereas PFR, it is converted into PR form in the presence of far red light. The phytochrome-mediated photoresponse. The phytochrome-mediated photoresponse can be divided into three categories depending upon the amount of light absorbed. Very low fluence responses, low fluence responses, and high irradiance responses. So these are the three categories. Now we shall go to each one and see what it is. The first one, very low fluence responses. These responses are non-photoreversible and are initiated by very low fluences. For example, in the plant Arabidopsis, stimulate seed germination. The second one, low fluence responses, these are photoreversible. It includes most of the red and far red responses. Example, the lettuce seed germination. And the third one, high irradiance responses. These require prolonged exposure to light of high irradiance. These saturate at much higher influences than low fluence responses and are non-photoreversible. For example, enlargement of cotyledons in mustard. These are the examples I have put for you of photomorphogenesis in plants. You can see in the first column plant group, the second column plants, the third developmental stage, and in the fourth column morphogenic response to red light. So you can see the morphogenic response to red light in the first angiosperms, in lettuce, that is in germination of seeds, in xanthium, inhibition of flowering, in Gymnosperm pinus, it stimulates rate of chlorophyll accumulation, and in the last one, that is a fern, it stimulates growth. So what is the importance of photomorphogenesis? We know that light influences growth and development of plants now. Of course, it also influences photosynthesis, but it also causes several responses in the plant body other than photosynthesis. And these responses influences the course of plant growth and final appearance. That is the photomorphogenic response. For example, seeds of many plants do not germinate unless they are exposed to light. So this is the importance of photomorphogenesis. I will give you a gist in this slide of the entire session what I spoke on now. What is photomorphogenesis and the details on it in this slide, that is the summary. The control of morphogenesis by light is photomorphogenesis. Large number of photomorphogenic responses in plants are known to be mediated by the proteinaceous pigment, which is a photoreceptor called as phytochrome. This pigment acts as a photoreceptor. It absorbs most strongly red light and far red light. It also absorbs blue light. The pigment phytochrome exists in two forms, One PR, that is red light, and the second PFR, that is far red light. These two forms are photochemically interconvertible. These are the references I've given to you. The first three are books. The fourth one, as you can see, is a website. Thank you very much, students, for watching.